In today's lesson, we're going to review how to solve systems of equations. That is something that you would have learned in Algebra 1. So one method of solving is by graphing. So we're just going to graph these two lines. So the first one, we're going to put a dot at -4, and then our slope is 2. So we're going to go up 2 and right 1, and then keep with that pattern, and then we'll make a line out of that. Now the second one, we're not quite ready to graph it because y is not by itself. So if we do a really quick division, divide everything by 3, there's your new line. So we're going to have to put a dot at 4. Because it's -2/3, for the slope I have to go down 2 and right 3, which would put me right there. Connect them, there's your second line. Now wherever these lines crisscross, aka intersect at, is the solution of the system. So the solution to the system lies at 3, 2. Right, so what that means is if you take your two starting formulas, y equals 2x minus 4 and 3y equals -2x plus 12, if you take those formulas and you substitute these numbers in for x and y, you should end up with the same thing on both sides. So we're going to go ahead and prove that. So according to my solution, my x's should be 3 and my y's should be 2. So I'm going to replace all my y's with 2's. I'm going to replace all my x's with 3's. All right, so if I do 2 times 3, which is 6, and then subtract 4, I will get 2. And I have 2 on this side, so I know I did it right because I got the same thing on both sides. Over here, if I do -2 times 3, that's -6, and then add 12, I get 6. 3 times 2 is also 6. So it checks out on both sides. That's what a solution does. It gives you the same thing on both sides. So there were two other methods that you would have learned in Algebra 1. One was substitution and the other was elimination. So we're going to go ahead and solve the system again, just using a different technique. And we already know what the answer is, so we'll know if we're right or wrong. So the key with substitution is you want to make sure that one letter is by itself. So you could get this y by himself, you could get this x by himself, you could isolate this x, but if you look, y is already isolated. He's the only thing on this side. So it would be smart to substitute 2x minus 4 in y's spot in the other equation. So when you substitute, you should always be plugging a group in to the other equation. And because you're plugging in a group of things, you have to put parentheses around it. So just a rule of thumb, use parentheses when you're substituting. So that's your new problem, and then we're going to go ahead and distribute. And I'm going to do two things at once. I'm going to plus the 2x to this side, and I'm going to plus the 12 to this side to get 8 and 24, and then if we divide, we get 3. So there's the 3 for the x. Now you have to go back and get your y value because there was another letter in the problem. So you can use either equation, it does not matter. However, this one is going to be less work for you. And you're going to substitute your x value that you found in x's spot. That's going to get you 2. So there's your solution, 3, 2. Elimination, same idea. We're going to solve for x and y, but you're actually going to start out a little different. You want to stack these up. It doesn't matter who's on top and who's on bottom. You want your y's together, your x's together, and then your constants together, just like that. And the goal is you want either to have the same number in front of your y's or the same number in front of your x's. So you can see these both say 2. So it looks like x is the way to go because they're already the same. And one of them needs to be negative. And we have that. So you are ready to actually add these guys together. So we're just going to add straight down. 1y plus 3y is 4y. 2 minus 2 is 0, so we just cross the x's out. We don't write 0x. And then -4 plus 12 is 8. And then you finish solving it. So y is going to be 2. Well, we were supposed to get 2 for y, so that's a good sign. And then again, you need to go back and get x. So you can use either equation, doesn't matter. I'm going to use the top one, that's a little easier for me. But I now know that y is 2, so I can replace y with 2. and then I simply solve the equation and get my 3. So we're going to do another system, and we're going to solve it all 3 methods just so you can see how they relate to one another. All right, we'll start with substitution. So obviously I want to use this because, well, y is already by himself. So it's a lot easier to take this group right here and put him in y's spot in the other equation. So instead of 2y, we're going to replace that with 1/2 x plus 3 and keep everything else the same. Then we're going to distribute. 2 times 1/2 is 1, 2 times 3 is 6. Then we're going to combine our x and negative x. Well, x minus x is 0, so that gives you 6. So this look always puzzles kids. They get 6 equals -4, and they're like, I did something wrong. Where did my x go? You didn't do anything wrong. All right, when this happens, that means there's no solution to the system. No matter what we try for x and y, we are never going to get the same thing on both sides. So it's kind of a trick question. So we're going to try that using elimination, see how that compares. So remember, elimination, you have to stack them up, but we have a slight problem. Y and x are on the left side in this equation, but only y is on the left side in the other equation. So it's up to you how you want to move things around. I thought it was pretty easy just to plus this x over to the other side, so that's what I did right here. Now I can take my second equation and plop it right under it, and everything's lined up nice and neat. Now you notice when you look at your x's, this has a 1 in front of it and this is a 1/2. So, I mean, you can try to get the x's to be the same, but it's probably easier to get the y's to match up. So if I want to multiply this bottom row by 2, I'll get those y's to match up. So the top is really not changing. In the bottom, if you multiply everything in this row by 2, you'll get 2, 1, and 6. See how you have the same numbers in front of your y now? We call those coefficients. You have the same y coefficients. That's what we want. The only problem is if I go ahead and start adding this, I'm going to get 2 plus 2 equals 4. I don't want to get 4. I want that to go away. So you're going to have to make one of them negative, and it doesn't matter. So a little trick I like to teach my kids is just pick one and change all the signs. So if you want to change this sign, you can, but then you have to do it to everybody. Kind of keep that balance. So change all the signs. And now you can add them together and your y's will go away. So that's great. However, your x's also go away, which doesn't usually happen. And then -4 plus -6 is -10. And then you get this weird thing again, 0 equaling -10. Well, again, that's not a true statement, right? So it's a trick question. There's no solution. Nothing I plug in for x and y will end up getting me the same thing on both sides. I'm always going to get this. Last but not least, we're going to solve it by graphing. So I'm going to go ahead and graph the easy one first. Y is already by himself. So go ahead and plot your dot at 3, and you're going to go up 1, right 2, and then draw a line. Now, your next equation, we got some work to do because y is not all by himself, is he? So you're going to want to move that x over, right? You just plus it, move it to the other side, change it to a plus x, and then divide everything by 2. So you'll get 1 over 2x, and then 4 divided by 2 is 2. That's the line we're going to graph. Put your dot at -2, go up 1, right 2, and connect. So if you look at these lines, they are definitely not crisscrossing, right? That's what no solution means. So we do have a term for those lines, and that is called being parallel. It's something you might have learned in geometry, or you should have heard it in Algebra 1. But that's what it means. So if there's no solution to a system, that means there's no intersection in the lines. The lines never touch, so they're parallel. We'll do one more system, but this time just using elimination and graphing. So I'm not going to use substitution. The reason I don't really want to use substitution is no matter which letter you try to isolate, like let's say you wanted to get this y by himself, you would have to divide everybody by 4. That's going to make a fraction. 6 over 4. It's not going to be a pretty whole number. Same thing for this. If you want to get y by himself, you're going to have to divide everything by 2 at some point, and we can't really divide 3 by 2 nice and pretty. So substitution probably wouldn't be good because no matter which way you do it, you're going to have to deal with fractions. It's a lot easier if you just stack them up, and they're already in order to do so. So this problem is totally set up for elimination. All right, then you have to pick, do I want the y's to be the same or do I want the x's to be the same? So it doesn't matter if you want let's say you want the x's to be the same. You got to multiply the top row by 2. You got to turn that 3 into a 6. So my top row is going to change, got to multiply everybody by 2, but my bottom row is not. All right, now my x's are the same, but one of them should be negative. So pick a row and change all the signs. Then you're ready to add them together. Now 6 minus 6 is 0. Negative 4 plus 4 is also 0. So on the left side, I have nothing. I have 0. And 20 minus 20 is also 0. Now this is different than what we just did because this is a true statement. So it's the opposite, where before it was no solution because it'll never work. This is infinite solutions because it will always work. No matter what I do, what I put in for x and y, I will always get 0 equals 0. So it's going to end up being a true statement regardless of what I use. I want to show you what that looks like from a graphical standpoint. So we're going to go ahead and start getting y by himself in the first equation. We're going to minus the 3x over, and then we're going to divide everybody by negative 2. Right, and then we went ahead and graphed the line. We start at negative 5, go up 3, right 2. Then we do our next equation. We're going to have to move the x over here and then divide everybody by negative 4. And then if you want to technically be correct, 6 over 4 is the same thing as 3/2. Now if I go to graph that line, it's going to literally be the same line that I just drew. So your equations are actually identical. So when you get infinite solutions for something, that means that you had the exact same equation from the start. It was just disguised. In fact, if you look at your two equations here, if you just double everybody here, you're going to get the same thing as here. So these are the same problem. I just had them disguised as different problems. So in short, the thing that they want you to take away from this in Algebra 1 was if you had lines that don't intersect, that means they're parallel. So if you have no solution, you got yourself parallel lines. And if you get infinite solutions, then your lines would actually overlap or be identical to each other. So that's the main takeaway from this. You're either going to have one intersection, no intersections, or they're going to be the same line, and they intersect everywhere because they literally lie right on top of each other. Now, we typically don't use graphing in Algebra 2 for systems. It's not a very practical way, especially if we get decimal answers. So when we do these problems, we're either going to do substitution or elimination. And it's going to be your choice. I'm going to let you know that unless substitution is clearly the easier route, I typically use elimination. So go ahead and close this lesson video out. When you're ready, go to the next lesson video and we'll start attacking these problems using one of those two methods.